Massive earthquake warning. The Tintina fault awakens. Imagine a 1,000-kilometer-long fault line, dormant for 40 million years, suddenly waking up and threatening to unleash a catastrophic earthquake. This isn't a scene from a disaster movie. It's a real possibility in northern Canada, where the ancient Tintina fault is showing signs of life after an eerie silence. But here's where it gets controversial. While some experts argue this fault has been inactive for millennia, new research suggests it's not just stirring. It might be on the brink of a major quake. Could this hidden giant be the next big seismic threat? Let's dive in. Stretching across the Yukon and into Alaska, the Tintina fault has long been considered a geological relic, a silent reminder of Earth's turbulent past. However, a groundbreaking study by researchers from the University of Victoria and the University of Alberta challenges this notion. By analyzing high-resolution satellite imagery and LIDAR technology, they uncovered evidence of two significant earthquakes. One 2.6 million years ago and another 132,000 years ago that reshaped the landscape. And this is the part most people miss. The fault has been eerily quiet for the past 12,000 years, which might not be a good sign. Here's why. The fault is shifting and building pressure at a rate of 0.2 to 0.8 millimeters per year. Over 12 millennia, that pressure should have resulted in a 6-meter slip, but it hasn't. When that energy is finally released, it could trigger an earthquake with a magnitude of 7.5 or higher. Geologist Theron Finley notes that while small quakes have been detected recently, there's no historical data suggesting the Tintina fault is capable of such massive ruptures. Until now, the researchers' findings, published in Geophysical Research Letters, highlight a previously overlooked seismic hazard. The fault's prolonged silence could mean it's in an advanced stage of strain accumulation, making a future earthquake not just possible, but probable. While the region isn't densely populated, communities like Dawson City, home to 1,600 people, are at risk. Beyond human lives, infrastructure and ecosystems could face devastating damage. But here's the controversial twist. Some experts argue that the fault's inactivity might simply reflect a stable tectonic regime, not an impending disaster. Others counter that the lack of recent quakes could be a red flag, signaling a dangerous buildup of pressure. What do you think? Is the Tintina fault a ticking time bomb, or are we overreacting to geological nuances? To better understand the threat, researchers are calling for more paleoseismic studies to determine the recurrence intervals of past earthquakes and whether slip rates have changed over time. The more data we gather, the better we can predict and prepare for future events. After all, in the world of seismology, knowledge isn't just power, it's survival. So what's your take? Is the Tintina fault a sleeping giant we should fear, or a geological curiosity we're misinterpreting? Let's spark a discussion in the comments. Because when it comes to earthquakes, the ground beneath our feet might not be as stable as we think. Canada's sleeping giant fault line, a major earthquake waiting to happen. A slumbering monster fault beneath Canada reveals its tremendous earthquake potential. Imagine a geological fault line lying dormant for millennia, suddenly showing signs of life. Such is the case with the Tintina fault, stretching across Yukon, Canada, and Alaska, which now poses a significant threat of generating a massive earthquake, according to recent research. This discovery highlights a previously overlooked seismic risk in northwestern Canada. Previously, scientists had assumed that the Tintina fault, spanning approximately 620 miles, 1,000 kilometers, from northeast British Columbia through Yukon and Alaska, had remained silent for the past 40 million years. However, a groundbreaking study published on July 15th in the Geophysical Research Letters Journal challenges this assumption. By analyzing high-resolution topographic data, a team of researchers discovered an 81-mile-long, 130-kilometer-long section of the Tintina fault that has produced numerous major earthquakes relatively recently. The last significant event occurred around 12,000 years ago, and since then, tension has been steadily increasing. When the fault eventually breaks, the resulting earthquake could be catastrophic, possibly surpassing magnitude 7.5. Such an earthquake would endanger small Yukon communities near the Tintina Fault, particularly Dawson City, home to over 1,500 residents. Intense shaking could trigger landslides and cause damage to nearby highways and mining infrastructure. In the past 2 decades, there have been minor earthquakes measuring magnitude 3 to 4 along the Tintina Fault, but no major ruptures, according to Finley. He and his colleagues embarked on a mission to determine if this fault could generate larger quakes. In recent years, there has been a significant increase in the availability of high-resolution topographic data, Finley told Gizmodo. His team utilized data gathered from satellites, airplanes, and drones to meticulously examine the area near the Tintina Fault for fault scarps. These distinctive features emerge when earthquakes fracture the Earth's surface, providing evidence of historical seismic activity. The researchers uncovered an 81-mile-long, 130-kilometer-long sequence of fault scarps located within 12 miles, 20 kilometers, of Dawson City. To ascertain the timing of the earthquakes that created these scarps, they analyzed landforms left behind by glacial incursions that took place 12,000, 132,000, and 2.6 million years ago. This analysis revealed that the fault has produced multiple large earthquakes over the past 2.6 million years, likely shifting several meters each time. Interestingly, the 12,000-year-old landforms showed no displacement caused by the fault, suggesting that there has been no significant rupture since then. Over these millennia, the Tintina Fault has been accumulating strain at a rate of approximately 0.2 to 0.8 millimeters per year, as stated in the study. Based on this, Finley and his colleagues estimated that roughly 20 feet, 6 meters, of accumulated slip deficit have built up. Ultimately, the accumulating strain will lead to the fault's rupture, potentially triggering a major earthquake, Finley explained. However, this doesn't necessarily mean the region is facing an imminent threat. While large earthquakes can occur on this fault, they likely happen with many thousands of years between them, Finley clarified. From our current understanding, we cannot determine whether such an earthquake is imminent or thousands of years away. Nevertheless, the potential for a significant Tintina earthquake necessitates a re-evaluation of the seismic hazard in northwestern Canada. Currently, Canada's National Seismic Hazard Model, NSHM, which influences seismic building codes and other engineering safety standards, does not acknowledge the Tintina Fault as a distinct seismogenic source, according to a University of Victoria press release. Finley's findings will eventually be incorporated into the NSHM and shared with local governments and emergency managers to enhance earthquake preparedness. Our data refines the location of areas with the highest hazards in this seismic hazard model, he stated. Tintina Fault, a hidden earthquake threat in Canada. Beware, Tintina Fault in Canada could trigger a major earthquake. Recent research from the University of Victoria has uncovered a seismic threat along the Tintina Fault in Yukon Territory, Canada. Despite being considered inactive for over 40 million years, a 130-kilometer segment near Dawson City shows signs of past earthquakes, hinting at potential future seismic activity. The fault, stretching 1,000 kilometers, has shifted 450 kilometers sideways over